Hey everyone, Dr. Crayhay here. So in this chapter on normal distribution, things get a little bit, they get a little sticky. So it's a little bit harder to understand. There's quite a bit more calculation. So what I'd like to do in this video is just walk you through a couple of your homework problems. So as you're watching this, I strongly encourage you, please do follow along, calculate this on your own, check your work as you go. It's all work towards your homework, so it should be very beneficial. Of course, you could just sit back and passively watch this video, but again, I'll reiterate, research suggests you'll get the most from this if you follow along with me, so please do consider doing that. So the first problem I'd like to do is 4a, and then we'll also do 4d, so 2 from number 4. So using the unit normal table, find the proportion under the standard normal curve that lies to the right of each of the following. So here I have a standard normal table that I use. This is it's just something I pulled off of Google. So I'll link to this. This is what I'll use in my videos. If you'd like to use this, you're certainly free to do so. There's also a copy in the back of your textbook that breaks it down a little bit further. So if you prefer one table over the other, please feel free to use whatever works for you best. This is the table that I'll use. I'll link it in this lecture video. It's in the course resources as well. So, using the unit normal table, find the proportion under the standard normal curve that lies to the right of z equals 1.00. So let me pull up my drawer here. So first question, 4a to the right of z equals 1.00. Now, pardon me for my chicken scratch here. So 4a from your homework to the right of z equals 1.00. A lot of people try to skip this next step that I'm going to suggest that you do, but I'm going to strongly encourage you, draw this stuff out. When I was first going through this, and even as I do it now, drawing really helps me understand what it's asking for, what I need to find. It feels a little silly drawing pictures over and over again, but I think it really helps us kind of see what we're doing visually rather than focusing on all of these numbers. So that's what I've got here. I'm really bad at drawing normal distributions, as you saw in the last video, so I've just copied some from the internet here. So in this top one, we'll do 4a. Now remember, standard normal distribution, so we've got our bell curve of data, right? So over here is the frequency, and over here is our score, whatever that happens to be. In the exact center of this distribution, we'll have our mean. In the standard normal, we would have a 0 here, right? So I'm just going to put a 0 here. This would represent 1 standard deviation. This is going to be 2. Right here we have -1. And then, of course, -2, this line right here. So now that I have that set up, I can say, what area is this question asking me to find? So I'm going to change to a different color, and we're looking to the right of z equals 1.00. That's this line right here. This is our z equals 1. It wants to know what proportion of people fall in this shaded green section. So what proportion of people will be in this curve? We know 100% of the people will be under the totality of this curve. We know if we divide it in the middle, 50 fall below, 50 fall above, but how can we get exactly to the right of z equals 1.00? So that's where I start. I draw the picture. The next thing we'll do is pull up this table that I've shown you. And let's just talk about how this is set up real quick. First and foremost, at the top of these tables, they're going to tell you what area they're giving you. They could give you the area to the left of a certain score. They could give you the area to the right of a certain score. They could give you the area between the mean and your certain score. So pay attention at the top of whatever table you're using to see what exactly it's giving you. This table that I'm using, this PDF, gives you the area to the left of your z-score. So just like I've suggested, they've drawn out the normal distribution and they've shaded the area they're giving you. So wherever your z is, the proportion is going to be to the left of that. Going down the left-hand side, you have your z-scores to 1 decimal place, so z 3.4. So say you needed 3.43, for example. So you would go down, you have 3.4, and then you'll go across these columns until you get to this 3. So that right here, this probability represents 3.43. So it's got to the tenths here, and then it gives you that hundredths decimal up top. So if we were looking, for example, say 2.04, we have a z-score of 2.04 and need to find that in our table, we would go down, well, let's say negative, because that's what we're looking at. We go down to negative 2.0, and then this score right here is 2.00, 2.01, 2.02, 2.03. Here's what we're looking for, 2.04. The probability to the left of a negative 2.04 is 0.0207. So that's our probability value, and our z-scores are along the outer edges here. So that's how you read the table. Now, our question asks us for the area, or the probability to the right of z is positive 1. We have to go to page 2 for that. Page 2 has our positive values here. So z-score of 1.00, scroll down. We've got 1.0 and then 0, 8413. So the area to the left of z is 1.00 is 8413. So let's jot that down real quick. So to the left equals 0.8413. There are two different ways to show these numbers. So you can think in decimal terms. In that case, the area under the curve, the totality of that area would be 1.00. And then, of course, you'll have numbers like this, 0.8413. If it's easier, on the other hand, for you to think in percentages, then you can say the total area under this curve is 100%. And then this, of course, would be 84% is to the left of z equals 1.00. So we know this part. Sorry, I meant to change my color there. We know that this pink shaded part, the area to the left of z equals 1.00, has 84.13% of the scores. So this is known. We know that big chunk. We know the full chunk. We need this green part right here. So to do that, we just have to do some subtracting, right? So I could either say, we know the total area under the curve is 1.00. We know the area to the left is 8413. So if we subtract that, we will then get the area to the right. You could also say percentages 100% minus 84.13, and you would get the same number. Alright, so we've got the total area under the curve is 1.00 or 100. We know the area to the left of z equals positive 1 is 0.8413. So if we subtract those two numbers, we can find the area to the right, which would give us the answer to our question. So I don't like to do anything by hand, so I'm just going to pull out the calculator real quick. 100 minus 84.13. So we know 15.87% of the scores fall to the right of z equals 1. So for A, our answer should be 15.87%, or if we're working in decimals, 0.1587. Same exact thing. One we're expressing as a decimal, the other as a percentage. Okay, so that's good. Let's move to one more though. Let me erase some of this mess real quick. So in 4D, we're again looking to the right of a particular z-score. So let's see what 4D is. So 4D is asking us for the area to the right of z equals negative, what is this? Negative 2.80. So again, I have a very beautiful normal distribution here that I'm just going to label with my standard deviations to make it my standard normal. 0 in the middle, and then 1, 2, negative 1, negative 2. Change my color here. So we're looking for z of negative 2.80. So we have to go negative 2.8 is probably somewhere in this area down here. That's pretty far over. So to the right of z equals negative 2.8. So we're looking for the majority of this, right? So it's going to be a pretty big percentage. It's going to be very close to 100%. It's almost the entirety of our graph. So we want to know the area to the right of z equals negative 2.8. Our next step then would be to pull up our PDF table. So we're looking to negative 2.80. So we pull this up, we look for z over here, negative 3, negative 2.8, negative 2.80. So the percentage to the left, because that's what this table is giving me, of negative 2.80 is 0.0026. The area to the left of z equals negative 2.8 was 0.0026. So again, that was just pulled up from here, 0.0026 to the left of z equals negative 2.8. So again, we have to find the area to the right of that. So we can just take 1, because we know, again, total area under the curve is 1.0026. Subtract that out, and we'll get to our answer. So let me clear all this. 1 minus 0.0026 equals 0.9974. 9974. So 99.74% of the scores fall to the right of z equals negative 2.8. So 5b is asking us for the area to the left of z equals negative 1.32. Again, I'm going to label this 0, 1, 2, negative 1, negative 2. We want the area to the left of negative 1.32. So here going from 0, negative 1, negative 1.32 is probably in this range somewhere. So it's looking for this area right here. So we know that's going to be a very small number. We know that from this 0 to the left, that would be 50%. So our answer should be less than 50%. So we have to go back to our table and find our z of negative 1.32. So pull this up, negative 1.3. Remember, we have to go over. This is 1.30, 1.31. So to the area to the left of 1.32 negative is 0.0934. So we can write that in our answer. It should be P 0.0934. You could also say 9.34%. Now, that's what the question was asking us for. It was asking for the area to the left of z equals negative 1.32. So we're done. That's it for that question. For 5, let's do 5e. 5e is asking us to the left of z equals negative 0.10. So again, first things first, let's draw this out. 0, 1, 2, drawing the standard deviations on there, negative 2. All right, so we've got a negative, so we know that we are to the left of this 0 point. We're not a full 1.0 yet, so we're going to be really close, maybe in here somewhere. Negative 0.10, very close to that 0 number. We want to note to the left, we shade that in. Now, because our z-score is so close to that 0, we know that we should be pretty close to a 50% in our answer here. Nonetheless, we still need to go to our z-table and look that up. So let's pull up that z-table. Now we want z equals negative 1.0, so 4602. 4602. P equals 0.4602, or 46.02% of the scores lie to the left of z equals negative 0.10. So 4602. So when your table matches up with exactly what the question is asking for, it's quite a bit easier. I mean, I know it was only one additional step in that last one. We had to subtract from 1 or from 100. But again, number 5, I think, should be a little bit easier for you. 6C is a little bit more complicated. It's asking for the proportion of scores between z equals negative 1.50 and we can just change our color here, and z equals positive 1.50. So again, draw out your normal distribution, label those standard deviations to make it the standard normal, and then let's just look at what our z-scores are. So on the left-hand side, we've got a z of negative 1.50. That's going to be halfway in between negative 1 and negative 2. On the right side, we have a positive 1.50. So again, right here, right in the middle of 1 and 2. And we want to know what proportion of scores is between these two. So I'm going to color all of this. This is what we are looking for. Now this is going to be a little bit strange because of the table that I have. It gives us the proportion to the left. So we'll say negative 1.50. The area to the left, let's go look that up real quick in our table. We'll find z equals negative 1.50, we've got 0.668. 0.668. So that's going to be, let me do this in a different color. That's this proportion right here. Right, so that's that proportion right there. So we're getting closer, but now let's look at area to the left of positive 1.50. Pull up our table. Go to page 2 for the positive numbers. 1.50, so the area to the left of z equals 1.50 is 0.9332. 0.9332. So that is actually from this point all the way over. So 93.32% of scores fall from this point right here of a z 1.5 all the way to the left of your distribution. We only want essentially this chunk right here. So again, we can just do some subtraction here. So if we take that full chunk, take out the piece we don't want, and that will leave us with that area in between. 9332 minus 0.0668. Again, I don't trust myself, so let's just pull up a calculator real quick. So we've got 0.9332. Again, you could do 93.32% minus 6.68%. Both would be correct. 0.0668. 86.64. 86.64% or 0.8664. You should be consistent, unlike me. So the area between a z of negative 1.5 and a z of positive 1.5 is 86.64. The majority of scores fall in that center area. Or, of course, you could write 0.8664. Both are correct answers to this question. The next question is going to be slightly more complicated. So let's see what we can do here. This is not from your homework, but there are questions like this on your homework. So here it is, this first one right here. A normal distribution has a mean equal to 100. What is the standard deviation of this normal distribution if 97.72% of the proportion under the curve lies to the left of x equals 108? There's a lot going on in this question. So the first thing I like to do in these kinds of questions is just write out my information. So let's see. I'm going to pull up my drawing board, and so I believe this is what you'll be able to see here. We know a couple of things. We have a mean. We have a mean equal to 100. We have that in the question. It is asking for the standard deviation, so I'm going to do standard deviation equals question mark. If 97.72 of the proportion under the curve lies to the left of x equals 108. So I'm going to write out our p, our proportion, 97.72%. We also know our raw score, so I'm going to denote that with x and then a lowercase 1. So it's raw score 1, x1 equals 108. So 97.72% of the scores fall to the left of x equals 108. We know we have a mean of 100. We're trying to find the standard deviation here. So how do we do that? Okay, so we've listed out what we know and what we do not know. We have a raw score of 100. We're trying to find the standard deviation. We know the proportion to the left of a raw score of 108 is the proportion is 97.72. We have one more unknown here. We don't have our z-score, so we're going to have to find our z-score. If you look in your textbook, you'll find the formula for that. Z equals the raw score minus the mean over your standard deviation. So using this, we can start to solve this problem. Now, to find the z, we have our raw score. We have our mean, but we do not have the standard deviation. What we do have is the proportion to the left of 108. So what we can do is go back to our unit normal table, and instead of searching by z-score, we can actually search by this proportion. So let's pull up that table and let me show you what I mean there. Here. Now, remember, this is actually giving us the area to the left of z. So if we can look down in here and find 97.72, we can get our associated p-value. So just starting here, we have 0.5, 0.6, 7, 8. All right, 9s, we're getting close. 97.13. 97.72. So the question told us 97.72% of the scores fall to the left of z equals 2. So we have our z-score now. Our z equals 2. So I'm going to erase that out, that question mark. Now we have a little bit more understanding. Z equals 2. Now we can start to plug these different things in to find those different answers. So we know our z-score, 2, equals our raw score, 108, minus our mean was 100, and then divided by the standard deviation. So you can, here we have to invoke order of operations. Please excuse my dear Aunt Sally. If you're a little rusty on this, I linked some extra lectures for you there. Khan Academy does an excellent job going through this, telling us, parentheses, exponents, then multiplication and division, addition, subtraction, so that can help you kind of catch up there. So we have this in parentheses here, so we know 108 over 100 is going to be 8 over our standard deviation, and then our z-score, 2 equals. To undo this division, we can multiply it by both sides. So let me scroll down. So we have 2 times the standard deviation equals 8. So if we divide both sides by 2, that will leave us with our standard deviation by itself. And we know our standard deviation is 4. Now, these questions, they're really great because you can actually go back to this z-score formula and check your work, right? So let's do equals our raw score again, 108 minus our mean of 100 divided by the standard deviation that we just found is 4. 108 minus 100 is still 8 over 4. 8 divided by 4 equals 2. Z equals 2, which is what we found at the beginning of the problem. So you can work all the way down to your answer, get your answer, and then plug it back into the formula, solving for something that you already have, right? So we could have solved for our raw score, we could have solved for the mean to check our work. For me, it was easiest to solve for z, so that's what we did there. We got the same number as before, so we know that we completed this problem correctly. Okay, so there's a very long lecture of me working through some of your homework problems, hopefully side by side with you. If you have any questions, comments, concerns, please do leave them in this video and send me an email if you need any more help.